Hi, today we're going to give a quick run through the scope and multimeter functions that are built into the Socio X6 and the Socio 410. So like we said in previous videos, the X6 and the 410 has this built-in 2-channel scope and multimeter, and other models, the X5 and X3, are just diagnostics. They don't have any scope or multimeter built in. On the X6 is the bigger tablet-based unit, so we can use the scope or multimeter directly on the unit, or if we wish through the PC. The 410 is a PC based. We can use the scope and multimeter through the PC, but we can also use the scope and multimeter on its own small screen. So for example, we go into volts, ohms here, or we can go into oscilloscope here. So we have our 2-channel scope up here. It's okay for certain jobs. Like we said, it's quite small screen, so for maybe some quick tests you can use it on its own display, but or you can use it then on the PC software. So with the kit then you have your 2 scope leads. And then there's a kit of back probes and some other crocodile clips and adapters. And then we have our PC based software that we can use both scopes through. But to be honest, on the X6 there's quite a big screen on it, so you will probably find most people will just use the oscilloscope and the multimeter on the X6 directly on the screen, but they also have the option to use it through the PC if they want. For the 410, like I said, the screen is quite small. You can use it directly on the unit, but we'd recommend when using it with the 410 use it through the PC. So we'll just go out to a vehicle here now and show some of the features and functions on the scope. Now, so we have the Socio X6 connected up to the vehicle here. Again, it's our own feature Cajo 2015 2.3 JTD. And we have it set in PC control mode. So the same would apply if you're using the Socio 410. We have our 2 scope leads connected up, so we'll be connecting to various things on the van. But we'll be recording the video through the reason we're doing it through the PC software. It's easier for me to record the video this way. Like we said, we can use it on this tool's own screen, but it's just easier for recording to do it through the PC. Right, so we'll just start showing it then with the PC software. One of the real nice features with this is we can have diagnostic data displayed and our scope or multimeter data displayed at the same time. We'll show this in a few minutes, but just to start off, we'll just show them operating individually. So if we just want to use the multimeter on its own, we just go in here. So we have our standard voltmeter on here. Volts, and you'll see the scale, everything automatically adjusts. It'll display min max here also. We can pause it, we can save it, we can open up existing recordings that are saved and play them. Also here you can pick whether you're using just standard volts or if you want to use an amps clamp. When we click amps clamp, it automatically sets it up in amps, and again the scale will be automatically adjust. So we can use it with Tecnomotor's 20 amps current clamp, 660 and 600. And also have then, just like any multimeter functions, our own meter. So we're just making and breaking the circuit here in the ohm meter. Also have a continuity tester with an audible warning. You probably can't hear the volume on the so that's nothing special, just your standard multimeter. We can open it up into full screen mode as well. We'll go back to here with the other buttons on the bottom. We'll just go back to home here then. Just go into the oscilloscope. So yeah, it's a 2-channel oscilloscope. They have some presets in here. It's called Easy Scope. So they have some generic presets, just a small amount at the moment. They may be adding more in the future. But like with the presets, it'll we pick a sensor or a component. Brings up some details about it here, some technical information, a picture of what the sample or the waveform should look like. So yeah, you can read through all this information. You can click here to carry out the test, so it opens up the scope here on the side screen. So that's using it with their generic information or presets, or if we just want to use it only use it on our own and just use the scope on our own, we just click here. So this, if we want to use Easy Scope, the information and the scope, or if we just want to use the scope. So it says 2-channel scope, so we can switch our channels on and off here. We have noise filters, our scale and our voltage scale adjustment is just done here. You can have it the AC or DC or AC coupled. Set our standard probe, or if we're using the 20-to-1 and attenuator. Settings here for current clamps. Offset on the screen, so we can have the 0 line lower down on the screen or higher up. So that's our settings for each individual channel. Then we have our time settings for our time base here, our trigger. So you can have it in channel 1, channel 2, and then you have auto, normal and single mode, rising or falling, or they call it up or down. Can zoom the same as most other scopes, zoom in on the signal. We have the buffer as well. We have cursors, time, amplitude, time and amplitude, value or cursor. Then you have some functions here, match channels and various other bits. So we'll just connect it up to some here just to take some measurements then. So now we're connected up to a common rail injector on this vehicle. You'll notice I have channel 1 onto the positive of this injector. You notice I'm only using one wire onto the injector and the other one to ground. The reason for this is this scope is not a differential scope. The grounds are connected together internally. So if I was to use both wires onto the injector to see the full signal, and then we accidentally connected the ground of channel 2 to ground, we'd create a problem, create a short. This is not, both models are non-differential scopes. This is not uncommon. A lot of automotive scopes out there are non-differential, so you need to be careful with this when you're connecting up, as the grounds are connected together internally. We're connected up to the injector. As you can see, we're getting nothing, just an odd flash on the screen. So we need to set it up set up the voltage scale, time base, trigger, etc. to get a signal displaying. So we'll go to 10 volts per division. Not sure if that's enough, but we can start off there.
We'll set her trigger to normal and set it to upward or rising. Then we'll move our trigger level up. Now you can see it's starting to draw the signal on the screen. Needs another little bit of tweaking. We can't see much detail here, so we'll decrease the time base a bit. Now we're getting a better signal, but we could go a bit lower. So now we have it displayed, and trigger seems to be holding it fairly stable on the screen. You'll notice when we're taking this, the fact that we're only checking to connect it to one wire on the injector, we're only seeing the positive part of the injector signal. If we were using our GMTO differential scope, we can go onto both wires and see the negative, the downward pulse on the injector signal also. But this is quite sufficient to see if you're getting a signal to the injector, if you have a non-runner, connect onto the injector, is it being pulsed, so on, and then we can analyze some other information by looking at the pulses here. So there is many other functions here, so we can pause it, bring up our cursors, amplitude, drag our cursor up to the top of the signal. You can see that and bring the bottom one up. So we can see the overall height of the voltage for the initial opening of the injector, the height of the voltage that it's using to keep the injector open during the on time. We can bring up our time cursors, move them around wherever we want on the screen, take measurements and look at the readings here on the bottom. So that's it on like I said, we're just doing a few quick examples just to show some of the features. Yeah, so sorry, there was a couple of other things there we just forgot to mention. So say, for example, we came back to a vehicle, this vehicle or a similar vehicle, and we wanted to measure the injector signal again. Instead of having to set up the voltage scale, the time base and so on, we can save a known good reference from this vehicle and use it then for future use. So say for example we'll just set this up again, set up our trigger, zoom over a little bit, increase our time base, a little bit more. So we can pause this, and once we have everything set up and we're capturing a good signal, and save it. So we'll just save this. So then, for example, say if we close the scope and we come back to this vehicle or a similar vehicle, and we want to just go straight back in, and instead of having to set up voltage scale, time base, and we want to have a known good reference to view. So here we're going back in, the scope is not set up, it's not really showing the proper signal, so we can pause the scope, go open. This is the last one we saved, I'm pretty sure. Go OK. So now we have our known good signal back up on the screen. Our voltage scale is set up, our time base is set up. The only thing it doesn't save is the trigger, so we just have to set the trigger back up again. So here is our known good. Here is what when we're going to start measuring, it will start displaying here. So now you can see it's moved slightly, but that's because I could have the trigger here in a different position. So yeah, you can see our known good saved and what we're measuring now. Also then there's other features like let's overlay this back over. There's other features then that I forgot to mention, like zooming, so we can zoom in on the signal. Brings up the little window here as well, and on zoom. There's few different zooming functions here. And then you have your buffer. This is where it collects screens, so you can scroll through the different screens here on the memory buffer. So as with that. Then, like we said, we went through the cursors. You have other functions here, like mathematics. You can invert the channel 1 plus channel 2 minus and so on. We'll just show one here inverting. So basically it's no advantage in this case, but it would be for other measurements. So yeah, that's about it there then. So just go back to the home, and just to show you what we can do then on where we can view diagnostic data and scope data or multimeter data at the same time. So we'll go last vehicles. I was already connected to this, so we're going to go into engine. It's this one, system diagnostics. So we can view our diagnostic data, and now we can get scope data up here as well. So what I'm just going to do here, maybe use an example if you had a vehicle with a non-start condition, so we can go, we'll just select, say, engine RPM, and fuel pressure. So okay. So then we can click, when we're in diagnostics, we click on the oscilloscope. So now it's open, we can see our diagnostic data and our scope data, but now our scope is not set up for measuring the injector. So if we just click here, now we can get in and set up our scope to suit. Go normal. Set the trigger, change the time base. So now we have our injector signal, and then we can go back to our diagnostics. So for example, if you had a non-start condition, we can be monitoring engine RPM while we're cranking, fuel pressure and injector signal all on one screen. So that's quite useful, and you can take any measurements you like here. You know, we could be monitoring fuel pressure that the ECU is seeing, and we could be connected to the rail pressure sensor here on the scope. So that's one thing. Another thing we could do is, in activations then, say for example, we could pick the likes of the coolant fan. We could, in this case, we have channel 1 wired up to the supply to the engine coolant fan. We can activate the fan and then look to see, are we getting the response from the ECU. So you see here we're getting the voltage supplied when it was running, and it's off. Activate again. So for example, this would help us to narrow it down. If we had a problem with the coolant fan and it wasn't working, we can go in here with the diagnostics, go electro fan and activate it, and then watch and see if the current or voltage is being sent to it. We could also have current up here as well with a second channel and an amps clamp, and then if we're getting the signal to it, then we can narrow down the problem further. So not just with that, we could do it with all sorts of other components here. For example, we could pick
EGR valve, connect on to the output signal from the ECU to the EGR valve, activate the EGR valve and see is it sending a square wave signal to the valve. So that's about it. Like I said, it's just to give a general idea on some of the features. It's not about showing how to use it, it's more about just showing some of the features that are available with these diagnostic tools with the built-in scope. So thanks for watching. Bye.